Find y in terms of x, given that 1 plus x dy by dx equals to that, and that y equal to 1 when x equals to 0. The curve passes through 2, 2, and has at xy given by the differential equation that. Find the equation of the curve. Show that the curve also passes through this point and sketch the curve. Shall we? We want to have 1 plus x dy by dx equals 1 minus x y, and when x is 0, y is 1. So they want us to find the original function. Yet again, we need to differentiate, but this time around we have to be careful as to how we rearrange it. So we can see that this is already dy by dx, and if we integrate with respect to x, we should have y in x, right? So I'm just going to rearrange the equation with the y on one side and the x on one side. So let's start by dividing both sides by 1 plus x to get rid of it over here, so that this will be dy by dx equals 1 minus x over 1 plus x. Y. I have to carry this y over to where dy is, so I'm going to divide both sides by y, and then this will be 1 over y dy by dx equal 1 minus x over 1 plus x. Since we have all the x's here, let's take this one to the right hand side. So it goes up over there, and we have 1 over y dy by dy equals 1 minus x over 1 plus x dx. So now we are going to integrate each of these sides. The integral of y is going to be natural log of y. Well, they haven't given us any interval, so it's an indefinite integral. So this will be plus c, right? And then on the right hand side, we have the integral of 1 plus x. 1 plus x can be rewritten as a term or a function with these partial fractions, right? So let's quickly get the partial fractions of 1 minus x over 1 plus x, like in the previous question. This is the same as negative x plus 1 over 1 plus x. Okay, let's put the integral here so that we don't forget that we have not differentiated it yet, integrated it yet. Okay, using long division, this would be negative x plus 1 divided by x plus 1. So x divided by negative x is negative 1. Then we have negative x minus 1, and then we subtract to get a 0. Then we have 1 minus minus 1, which is positive 2. So this is the same as having the integral of 1 whole plus the integral of 2 over x plus 1, which is equal to negative x, and then integrating this one, you should have 2 natural log of x plus 1. If I continue from here, this would be natural log of y equals, well, I can only put the c on one side, so I'm just going to choose the x side since it is dependent on x. So I'm just going to have its derivative, its integral here, plus its constant of integration. Now, they told us that when y is 1, x is 0. So in this case, I'm going to replace x with 0 and y with 1. So natural log, Okay, there's not enough space. So natural log of 1 should be equal to negative 0 plus 2 natural log of 0 plus 1 plus c. Natural log of 1 is always 0, 0 plus 2 natural log of 1 plus c. This would be a 0 as well, 0, 0, and then plus c, so c is actually 0. Okay, c is 0. That boils down to a natural log of y being equal to negative x plus ln of x plus 1 squared. I decided to bring the 2 to the top. I'm just going to resize this. The curve passes through 2, 2 given by the differential equation y e to the power y dy by dx. Find the equation of the curve. So we have to find the original equation of the curve, just like this one, right? So we have second part y e to the power y dy by dx equal to e to the power 2x. So we have to integrate again, rearrange these according to variables. So y will be on this side, and then e to the power 2x dx will be on that side. Integrate them separately. Well, this one looks easier to integrate, so I'm going to start off with that one. So integral of e to the power 2x, we're going to let u be 2x, so that the derivative of u would be 2. And then this will be the integral of e to the power u dx. But then dx, this was du by dx. So dx can be replaced with 1 over 2 du, so that we integrate u with respect to u. The integral of e to the u is still going to be e to the u. So e to the u over 2 plus a constant. That's it. So now for integral of y to the power e y dy, we use integration by part again, where integral of u dv should be equal to uv minus integral of v du. So I'm gonna let u be, in this case, the y, dv, pardon me, by e to be e to the power y. Okay. Lastly, if I want to differentiate this, du would be equal to 1, and then dv, which is e to the power y. If I integrate it on both sides, I will get v equal to e to the power y. It's just going to stay the same. So then integral of y e to the power y dy should be y e to the power y minus integral of v, which is e to the power y du. Du was 1, so that's 1. Okay, this should be y e to the power y minus integral of e to the power y is still the same as e to the power y. So this would be equal to y e to the power y minus e to the power y equals e, the right hand side, which was e to the power 2x over 2 plus c. And then they told us it passes through the point 2, 2. So when x is 2, y is 2, right? We can find constant c. So at 2, 2, we should have 2e squared minus e squared equal to e squared plus c. And then 2e squared minus e squared is just going to be e squared. And then e to the power 4 plus c. So then in this case, this is over 2. E to the power 4 over 2. So then we should get e squared equal to e to the power 4 over 2 plus c. And this implies c is e squared minus e 4 over 2. Okay, it means that our function would be, let's get it from here, it would be y e to the power y. Okay, I can factor out e to the power y minus 1 equals e squared x over 2 plus the c, e squared minus e to the power 4 over 2. To simplify it, we should get our equation e to the power y minus 1 equals e squared x minus e to the power 4 over 2 plus e squared. Or we just put this on the same denominator, 2e squared. And there we have it. The next part says that we should prove or show that the curve also passes through this point, and we sketch it. So point 1 root 2, so 2.1 root 2, it means that when x is 1, y should be square root of 2. So we simplify and we substitute x in there. So the left hand side must be equal to the right hand side. So 2e to the power root 2 minus 1 equal to e to the power 2 times 1 to the power 4 plus 2e squared over 2. Okay, use your calculators, and if you plug this in, you would see that the left hand side would give you e squared times square root of 2 minus 1, which is 4.11. And then the right hand side, which is the same as e squared plus 2e squared, is 3e squared minus e squared e to the power 4 over 2. Okay, the right hand side would be 3. The left hand side is not equal to the right hand side, so it means that the question probably had a mistake, because this is the equation that I got even after working out this question a couple of times before bringing it on to YouTube for you guys to see. I worked it out and I had this equation twice at the end of the day. So that's probably a mistake. But then if you want to sketch this out, you can use decimals. I'm just going to put in the formula and you work it out just like so. That brings us to the end of this walkthrough. And if you found it helpful one way or the other, make sure to give me thumbs up. See you in the next